Welcome friends, my name is Satyajeet Sahu and today we'll have a wonderful session, 100 MCQs, and name of this session I have given is what? Fast and Mixed Civil. Now many of the students might be thinking that what is the secret behind this name, that why this name Fast and Mixed Civil. I will tell you the reason. Yes. Now first of all, I will try to rectify a fault or a flaw in your preparation. What is that fault? Whenever we are preparing for examinations like GATE, ESE, one mistake we do always. We normally study a subject continuously for 5 days, 6 days, 10 days, sometimes 1 month. Yes? And what happens? Whatever we studied previously, we forget that. We don't revise them. Or even if we revise 1 or 2 subjects. Yes? But we know that in GATE and ESE, there are more than 10 subjects, right? So it's very important that we, in between our preparation, attempt questions in such a way that we have questions from many subjects, 7 to 8 subjects, right? And by this, we will keep our mind updated for the examination. Because in the examination, questions won't be asked in subject wise, 2 subjects or 1 subject. No, they're going to ask from 10, 12 subjects. And if your mind is not prepared in this manner, then you will face difficulties. So today's session is Fast and Mixed Civil. Yes, mixed. Why mixed? Because it will be a combination of 7 to 8 subjects. So it's a mixed. Okay, and I am not going to tell you which subjects. It was mystery. Yes, and why fast? Because we'll be solving objective questions, straightforward question in a very fast manner. I'm not going to give you a lot of time. Yes, so I'll request all the students who are attending this session live or recorded, what you do, you bring your pen, paper, yes, and sit, okay, and solve them very fast along with me. So if you are live, then you can solve with me, or if you are not live, you are seeing this lecture recorded, then I will request you still don't pause, attempt this whole 100 questions. Attempt this whole 100 questions in a time framed manner. Okay, so let's start the session. So I'll be starting with question number 1. So hope all of students are ready. Let us start the session without any further delay. So this is your first question, right? This is your first question. The question is, while designing an highway, identify the factor which is not taken into account for computation of braking distance. So this is the question number 1. I'll write down question number 1. Yes, it is from highway engineering. So I will wait for your answer. So please mention the answer in the comment section and then I will tell you the right answer. So please, I'll wait for your answer and then I will go to the answer. Okay, so write down your answer. And I will give you very less time. So it's very fast, right? I'm going to give you very less time. So if you're unable to answer in a limited time, then I'm going to the next question. Yes, as Arman has answered, it is what? Reaction time of the driver, right? Now what is the braking distance? It is v square by 254 f plus minus 0.01 n. Yes, this is the braking distance depending on speed, depending on gradient. This is gradient, n is gradient, right? And f is what? The friction factor, but doesn't depend on what? The reaction time. The reaction time affects what? The lag distance, not the braking distance. So this is the right answer. So question number 2, yes. Now question number 2 is from Geotech. You see, I told it's a mixed civil, Geotech. So answer this question. Degree of saturation is given. Degree of saturation is given 67.89. What is the air content? What is the air content? So answer very fast. Come on. What is the air content here? Answer very fast. Come on, fast. See, yes, because the degree of saturation plus air content is what? It is 100%, right? So from here, air content will be 100% minus degree of saturation. That is how much? I am getting 32.11. Very good, Arman. So this is the right answer. So first question, let me write down the subjects also. So first question was from highway engineering, right? First was from highway engineering and second question was from Geotech. Second one was from Geotech. So we'll be mixing the questions. So question number 3, okay, RCC. Answer this question. Lateral ties are provided in RCC column. Lateral ties are provided in RCC column for what? Come on, answer this question very fast. I am waiting for your answer. Lateral ties in RCC columns are provided to resist what? Yes, as Praveen has answered, it is buckling of longitudinal bars. Yes, so these are the longitudinal bars. Yes, these are the longitudinal bars in a column, and we provide the ties like this. We are providing the ties like this to avoid the buckling of this longitudinal bars. Yes, buckling of this longitudinal bars. Correct answer. So this is from what? This is from RCC. Next question, question number 4. Question number 4, it is also from highway engineering. So answer this. Camber. For a road with camber of 3%, yes, design speed is given. The minimum radius of curve beyond which no super elevation is provided. So no super elevation is provided means what? This camber only becomes what? This camber only becomes the design super elevation. This camber only becomes the design super elevation, and you know the formula for design super elevation. Put that and give me the radius. Give me the radius. The design super elevation is how? What is the formula? It is b square by 225 r. This is the formula, right? So here the camber becomes what? The design super elevation. Yes, that means this is equal to 0.03. B we will take in what? Kilometer per hour, that is 80 kilometer per hour, so 80 square. Now divided by what? Divided by 225 r. So from here you can find out r, and r will be in meter. This formula is designed in such a way that r will be in meter. So what is the right answer to this? Please write in the comment section. What will be the right answer to this? Come on, fast, fast. It's fast civil. Fast civil. We have to solve very fast. No delay. Come on, what is the answer to this? How much are you getting? I am not going to solve. I will depend on you. I am going to guide you. So what's the answer to this? I can say this will be 80 square divided by 225 and then divided by 0.03. Getting 948? Yes, this is the right answer. So question number 5 now. Okay. Question number 5. What is the valid relationship for minimum shear reinforcement? Again another question from RCC. So you are mixing the question and solving them, because in the final examination the questions will be mixed in nature. So what is the answer to this? What is the answer to this? I will give you a hint. The spacing formula is what? 0.87 Fy ASB divided by what? Tau V minus tau C into B. Whenever we are discussing about the minimum shear reinforcement, what you will do, you will replace this tau V minus tau C with 0.4. Now see which is the correct relationship. So here I can write down 0.4 B into SB less than equal to 0.87 Fy ASB. As many have answered, this is the right answer. So very happy to see a lot of enthusiastic participants. So I must congratulate that those students who are attending this session. That means they are very serious about their preparation, and also they have reached, I can say, advanced level of their preparation where they are into practicing questions. So I will be conducting many such sessions in the future also. So congratulations to Praveen, Akshay, Ayush, Swaroop, Sasaroop, Arman, David on Hill. So congratulations that you are preparing well. Don't give up the preparation. Continue. As you can see that most of you are solving the answers very correctly. So continue it. Question number 6. Okay, now answer this from Geotech. Question number 6. Inorganic clay of high compressibility. What is the symbol to this? Inorganic clay of high compressibility. Inorganic clay, okay, of high compressibility. What's the right answer to this? Yes, it is B. C for clay and I for high compressibility or high plasticity. Yes. Question number 7. So this was from your Geotech only. This was from your Geotech. Question number 7. Question number 7. Come on, very fast. Depth of tension crack. Depth of tension crack. So this is also from Geotech. Okay. So depth of tension crack. Okay. The undrained shear strength is given. Undrained shear strength is given. And undrained shear strength is equal to what? The undrained cohesion, right? So the undrained cohesion or cohesion is given to us. Okay. Unit weight is also given to us. Okay. You have to find out what? The depth of tension crack of a cohesive soil. Cohesive soil means what? The phi is 0. 50 means what? Ka is 1, right? What is Ka? What is Ka? Ka is 1 minus sine phi by 1 plus sine phi, right? So if phi is 0, then Ka I will get 1. Now find out the depth of tension crack. What is the depth of tension crack? What is the formula? The formula is 2c by gamma root Ka. This is the formula, right? So I can say 2 into c. C is how much? C is given 40. Divided by what? Your gamma is 16 and then Ka is 1. So I am getting how much? I am getting 5 meter. The answer is 5 meter. B. 5 meter. It is what? Depth of tension crack. Depth of tension crack. See, if they are asking you critical height, na? If they ask you critical height, that is 2 times of your tension crack. Yes or no? If they ask you critical height, that is 2 times of tension crack. It is what? Only depth of tension crack. Very good. Question number 8. So again from RCC now. So we changed our subject from RCC. So little tricky question. Flexural cracks appear at bottom of a beam at tensile stress of 3.13 MPa. Means what? This is your modulus of rupture. Because at modulus of rupture you get the tension cracks. Okay. 4c by gamma is for the critical height. 4c by gamma is for critical height. It is tension crack is different. Okay. So FCR is given as 3.13 modulus of rupture, right? And this is what? This is 0.7 root FCK. It is 0.7 root FCK, right? And what is asked? Design compressive strength. The design compressive strength formula is what? 0.45 FCK. Yes or no? Design compression formula is what? 0.45 FCK. So what you are going to do? You are going to first of all find out the FCK from here. Okay, and then put here and give me the answer. Now solve this question. Okay, I give you some time. A little numerical nature. We'll solve some numericals also. Okay. Okay, some students have solved. Very good. See, if you solve this now, you will get FCK is equal to 20, right? You'll get FCK is equal to 20. So this will be what? 0.45 into 20. So that is 9 ampere. Very good. Question number 9. So open channel flow. Yes, question number 9, OCF. As I told, we will be mixing the subjects because in the final exam, all subjects will be coming. Therefore, this mixed and fast civil sessions are very important. Come on, very fast. In hydraulic jump, flow changes from where to where? Hydraulic jump, flows changes from where to where? This is a hydraulic jump, yes. This is a hydraulic jump. Okay. So what is the flow here and what is the flow here? Come on. Yes, it changes from supercritical to subcritical. Here the flow is supercritical. Yes, that means what? The Froude number will be greater than 1. And here it is subcritical. Here it is subcritical. Very good. Next question. Question number 10. Okay. From traffic engineering. Okay. Question number 10 from traffic engineering. Solve this question. The free mean speed is given, right? The free mean speed is given. It is given 80 km per hour. That means what? This is your VSF. Now, under stopped condition, the spacing between the vehicles is given. This is the spacing within the vehicles at stopped condition. Means what? Jam condition, right? Determine the capacity. Capacity means what? The maximum flow. Capacity means what? The maximum flow. Right? And we know the capacity or maximum flow formula is what? It is VSF into Kj by 4. But how to find out Kj? Kj is nothing but 1000 by the spacing under jam condition, right? So this I can write down as 80 into 1000 by 8 given, yes? And then further divide by 4. So how much are you getting? You are getting a value of 2500. Yes, very straightforward questions. So 10 questions we have completed. You have to go very fast. Question number 11 again from highway engineering. Question number 11 from highway engineering. Come on, solve this question. Grade compensation. Highway engineering, grade compensation. I will not help you now. I'll give you some time. You have solved it. Come on, fast. Come on, fast. Come on, fast. Come on. I'll have some water by that time. See, 1 in 20 means percentage by how much? Percentage wise, it is 5%. It is 5%. Now grade compensation means the reduction. So grade compensation is what? It is 75 by R, or how much? 30 plus R by R. You can see that if R is 200, obviously this will be very large. So to take the minimum one, so 75 by R, right? So 75 by R, which is 200, I will get 0.375 percentage, right? So round figure is what? 0.38%. Is very good. Question number 12, and this is from Geotech. Come on, solve this question. Question number 12, Geotech. The stress at a point Z depth below a line load. Below a line load, if we have a line load, yes, then what is the stress at a point Z depth here? What is the formula? What is the formula? Let us see who answers this question correctly. Fast, fast, fast. No time, no time. You have to do it very fast. To complete the whole session, we have to complete the whole session before 1 hour. Not 1 hour, 75 minutes. 75 minutes, 100 questions. Yes, the answer is D. 2Q by pi Z square. If it was a point load, what is the formula? Point load is 3Q by 2 pi Z square, right? Point load, just below the point load, it is 3Q by 2 pi Z square. It is 2Q by pi Z, not Z square, Z. Yes, very good. Question number 13 from RCC. Okay, so we switch the subject. So for a span of continuous beam of length 13 meter, what is the allowable? What is the allowable span by depth ratio? Yes, correct, Akhil. Not Z square, only Z. Okay. Span by depth ratio. Come on, fast, fast. Come on, very fast. Come on, ladies and gentlemen. Span by depth ratio. Chalo, chalo, chalo. Span by depth ratio. Span by depth ratio. See, the ratios are 7, 20, 26, right? For cantilever, simply support and continuous. But here, this is for span less than 10 meter. Otherwise, we multiply what? 10 by span, right? Otherwise, we multiply what? 10 by span. So, span here is 13. So, you can see getting how much? 20. Very good. Question number 14. Okay, from soil mechanics. From soil mechanics, very fast. Grain size distribution. Grain size distribution. Grain size distribution. Okay, what is the answer to this? Steep graph. If we have a steep graph in your grain size distribution, then that means what? Steep graph, like this. What is the meaning of this? Yes, it is uniform graded. See, that means what? Most of the particles lie in this small range. Means uniform size, uniform graded. Very good. Question number 15. Okay, again from OCF. Question number 15, again from OCF. Come on, answer very fast. For an efficient rectangular channel, yesterday I took one video on this. Okay, for an efficient rectangular channel or section, hydraulic radius is found to be 0.62. The width of the section. What is the answer to this? Let us see who answers this correctly. What is the width of the section? See, hydraulic radius is given as how much? 0.62 meter. Now that is what? Y by 2 now for a hydraulic efficient rectangular channel. Yes. So I can say Y is how much? Y is 1.24 meter. And what is the width of a hydraulic efficient channel? It is 2Y. Yes. So answer is what? 2 into 1.24 meter. How much is the answer? 2.48. Understood this? Understood this? See, hydraulic radius is given this one. And this is Y by 2. We know the formula. Yes. This is for an efficient rectangular channel. Yesterday also I took one video in the round series also I taught this, right? Yes. Everybody clear with this question? Everybody clear with this question? Yes or no? Answer is 2.48. Everybody is clear? Akhil has answered correctly. Shall we move to next question? Yes. अरे बाबा clear ना? Clear नहीं है? Clear हो गया? हो गया? Okay. Okay. Let us go to the next question. The next question is this. This is question number 15. 16. Come on, fast. We are going little slow. We are going little slow. Let us be fast. Let us be fast. Question number 16. Ultimate settlement of a 4-meter clay layer. So again from soil mechanics. Okay. Surcharge is 12 kilonewton per meter square placed on ground level. What's the formula? Delta H equal to mv delta sigma into H. This is the formula. Now I have told in many videos that whenever there is a surcharge, the increase in stress at any point will be equal to the surcharge. So delta sigma will be equal to the surcharge, right? Now MV is given, H is also given, right? They have asked in mm, so I'll put this as 4000 mm. So what is the right answer? It is 5 into 10 to the power minus 4. The stress increment is 12. You see the units is what you see? It is meter square per kilonewton, and this is kilonewton per meter square. So these two gets cancelled, right? And then this is 4000. I can say 0.4 into 10 to the power 4. Yes. So this get cancelled, and this is what? 2 into total, that is 24 mm. Very good, straightforward question, right? Question number 17. Okay, from railway engineering. Question number 17 from railway engineering. Come on, answer this from railway engineering. Okay. The ruling gradient is given 1 in 250. If you find out percentage, this is what? 1 by 250 into 100. I can say this is 0.4 percentage. The horizontal curve is 3 degree. Yes. So what is the permissible compensated gradient? Yes. So first you find out the grade compensation. Yes, it is BG track, means what? The grade compensation will be how much? 0.04 into the degree. So this is 0.12 percentage. So I can say the compensated gradient, many students have answered also, very good. The compensated gradient will be equal to 0.4 minus 0.12, that is how much? 0.28 percentage, and 0.28 percentage is what? 0.28 by 100. So this is what? 1 by how much you are getting? 357. Nah, 1 by 357 you will get. 1 by 357. So answer is what? 1 in 357. Understood? Very straightforward question. Very straightforward question. Question number 18. Okay, something from strength of material now. Something from strength of material. Som, chalo answer karo. Som, the ratio of modulus of elasticity or Young's modulus and modulus of rigidity is given how much? If the Poisson's ratio is given as 0.2. Very straightforward question. You need to know one very simple formula. What is the answer to this? Come on, very fast. Very fast now. I'm going slow. We are going slow. No. We have to make it fast. How much is this? Tell me, ladies and gentlemen. Kitna aaya? The formula is 2 into 1 plus mu, na? So what is the answer now? It is 2.4. Very good. Next question, question number 19. Anchorage value, RCC. RCC returns. RCC returns, tell me. RCC returns. The anchorage value for a 135 degree bend in 20 mm dia bar is how much? Anchorage value for 135 degree. For 45 degree the anchorage value is 4.5. Yes. For 90 degree it is how much? 8.5. Right. For 135 it is 12.5. And for 180 degree bend it is 16.5. So the answer is what? 12.5. So 12 into 20, that is 240. Correct. Everyone is very correct. Very good. So we are going very fast. Very good. Question number 20. Now traffic engineering returns. Question number 20. Very typical question now. This is a typical question, and many students will be thinking, sir, why we are solving all the typical questions? Because in many, when you see this year ESE examination and GATE exam, many questions are very simple also. In every paper, there will be 40% or 50% questions which will be like this, straightforward, right? So we need to practice this question, and yes, in the individual sessions, I will be conducting tough, difficult questions also. I'll conduct some sessions on difficult questions also. But we need to balance the tough questions also and easy questions also. So everything has to be balanced, otherwise forget the easy questions. We feel this is easy, we leave, examination it comes and we forget it. Yes, so we'll not forget. So to solve this question, what is the answer to this? A. Okay, so you can see that what is the BSF? BF is when K is 0, right? So K is 0 means BSF is 55. And Kj is what? When BSF is 0. That means what? 55 by 0.44. So I can say 5500 by 44. So 4, this is 500. I can say 125, right? So the maximum flow will be BSF into Kj by 4. That is 55 into 125 by 4. You are getting how much? A. This. Approximately you will get 1718. Correct? Next question. Question number 21. Okay, RCC returns. Very straightforward question. Very straightforward question. Answer this. Okay. Now in the next month, okay, in the next month I am going to take some sessions for difficult questions also. Yes, we will have balance of difficult questions, easy questions like this, fast and civil. So I'll do different type of sessions. Okay, so very good. Minimum is 0.8 and maximum is 6%. Question number, it was RCC. Let us go to some SOM also. 22. Okay, strength of material, shear stress distribution. Okay, answer this. SOM, strength of material, shear stress distribution. So you can see that this session has predominantly questions from Geotech, Transportation, RCC, OCF and so on. In this session I am not touching fluid and environment. I will conduct separate session for fluid and environment. Answer is which one? A, B, C, D, E, F, G, H. Which one? Answer is A. See, shear stress is inversely proportional to B. Yes. So what happens? You see here, if you see the distribution, here it varies parabolically. Then what happens? At this section you can see that what has happened. At this section the width increased, right? Width increased means the stress will reduce. Yes. And then here the width increases. So stress again increases. Understood? Yes. So answer is A. We use this relation. Shear stress is inversely proportional to width. Yes. And it follows parabolic distribution. And at top 0, bottom 0. Question number 23. Very easy question from building material. The mixed design code is which one? Mixed design code is which one? What is the code for mixed design? Very fast. Come on, fast. Yes, 10260. Yes, this is for ductile detailing. This is for what? This is for ductile detailing. Very good. Next question. This is from, I can say, BMC, building material. Next question 24 we have from airport also. 24th question, it is from airport engineering. Please answer this question. The runway length after the elevation and temperature correction is this one. Yes. The effective gradient is given 0.5%. What is the revised runway length? Very straightforward question. Please answer this question fast. Yes. And we know what is the correction. For 1% gradient, we have to increase the runway length by how much? Increase by 20%, right? And here the gradient is 0.5%. So we have to increase the runway length by how much? 10%, right? Yes. So I can say this revised runway length increase by 10% means what? 1.1 times of 2845. It amounts to almost this one. Approximately 3129 something. So 3130 meter. Understood? Next question, 25th question. Okay, very straightforward. Now some questions from your steel structures also. Very good. Among the different modes of failure given, identify the one which is not. Very important in the examination. Many students, don't see the question. Sometimes it is written is not, or it is written is not correct, or is like this. So answer is what? So for tension members of steel, which is not, answer is what? Crippling. Because there is failure by rupture, yes, or fracture, There is failure by block shear and there is failure by yielding also. But that doesn't happen in crippling and tension members. Crippling mostly happen where? In compression members, okay? And in beams also. 26. The minimum eccentricity in columns, RCC. The minimum eccentricity for which the columns are designed. Answer this question. Come on, very fast. We have to complete in 75 minutes. We are going slow. Answer is C. Minimum eccentricity is C. 20 mm or L by 500 plus least lateral dimension by 30. Yes. Yes, this is the formula. So 20 mm is the answer. 27 question. Okay, from soil mechanics. 27 question from soil mechanics. The slope of E versus log of sigma. What is this? Slope of E versus log of sigma. What is this? Tell me. We get a straight line. What is the slope of this? The slope is what? I can say slope will be delta E by log of sigma 2 by sigma 1, right? If we take 2 points. So what is this known as? What is this known as? Tell me. What is this known as? This is compression index. Yes, this is nothing but compression index. Correct answer. 28th question. Okay, something on SOM. Shaft, power, etc. So SOM, strength of material. Come on, fast. Answer fast, answer fast, answer fast. 28 questions. You have done 28 questions from different subjects in half an hour. We have to be little more fast. Come on. What is the answer to this? What is the power formula? It is 2 pi NT by 60,000 if you are interested in finding the power in kilowatt. So what is the answer? 2 pi N is 150 and T is given 1500, right? Divided by 60,000. So 3 zeros get cancelled, right? This is 4 and this is 2. So I am getting how much? 7.5 pi kilowatt. So answer is C. Very good. Question number 29. Building material. Okay. Test on building material. Okay. Test on cement. Please match the following and give me the answer. I'll give you some time. Match the following. Do it nicely. Match the following. Do it nicely. एक से आ गया. Very good, smart. So the options are not smartly designed then. Soundness test is what? Leach-Atlas apparatus. Fineness is by air permeability. Setting time by cut abrasion and tensile strength briquette. So P is 2, Q is 4, R is 1 and S is 3. 2, 4, 1, 3. So answer is B. Correct. 30 question. Okay, something on pre-stress now. Okay, something on pre-stress. Deflection in case of pre-stress. So pre-stress concrete. See, RCC is different from pre-stress concrete. Yes, RCC is different from pre-stress concrete. I always treat it differently. The answer is what? PEL square by 8EI is the deflection, right? Deflection, if we have a pre-stress concrete beam, then deflects like this due to the bending moment created by the tendons. So this central deflection is how much? This is PEL square by 8EI. Next question, 31st question, right? Okay, something on airport engineering. The air reference temperature, ART, airport reference temperature. Very easy question. Very easy question. Please answer fast. You see, so many topics I have mixed. So individual topics also I will be conducting some sessions in the future. Yes, but every 15 days or 1 month we will have this 100 question sessions also, which is very important, and we will increase this frequency as the exam approaches. And there will be more sessions. I will be conducting some sessions for long type questions also. So many type of sessions are coming up. Answer is what? क्या आंसर क्या है? See, it is 40 plus 49 minus 40 divided by 3. So answer is 43 degrees centigrade. Very good. 32. Okay, strength of material. Answer little attentively. Strength of material. Answer little attentively this question. In a triangular section where the maximum shear stress occurs. Answer this question little attentively. Answer this question. For a triangular section, shear stress is maximum where? Yes, it is D. Very good. Yes, it is D. See, if you see the shear stress distribution is something like this. Yes, the neutral axis is at h by 3. You see, the neutral axis is at h by 3. Yes, this is the neutral axis. But we don't get the maximum at neutral axis. We get the maximum at the mid height only. Yes, and this maximum one is how much? This maximum one is 3 by 2 of average shear stress. Whereas at neutral axis, this is how much? This is your 4 by 3 of average shear stress. And obviously this is 1.5, right? And this is 1.3, right? 1.33, right? So obviously 1.5 is more. Yes. So answer is h by 2. Very attentive, right? 33 question. Okay. So bearing capacity, I can say foundation engineering. See, I treat soil mechanics as different from foundation engineering. Foundation, or I can say foundation belonging to geotech. I normally treat it differently. So what is the answer to this? Identify the factor that doesn't affect the bearing capacity of a purely cohesive soil. Identify the factor that doesn't affect the bearing capacity of a purely cohesive soil. Purely cohesive soil. In a purely cohesive soil, what happens? The N gamma is 0, right? The N gamma is 0. Okay? And we know that if N gamma is 0, NC is 5.7. Yes? Doesn't affect, it doesn't depend on the width of the footing. Why? If we see the equation, the last term is what? Which is having the, is the last term, right? We have, you see, CNC plus QNQ plus this. So when N gamma is 0, so what happens? These terms vanishes. So it becomes independent of width of footing. 34th question. Which of the following losses is not found in pre-tensioned concrete? So from pre-stressed concrete. 34, 34. Pre-stressed concrete. What is the answer? Which of the following losses is not found? Which of the following losses is not found? Not found overlap. Okay, very important. Not found. Not found. So in shrinkage, friction, creep and relaxation of steel. Which is the right answer? Yes, the right answer is friction. See, shrinkage, creep and relaxation of steel. All these three are what? All these three are long-term loss. All these three are what? Long-term loss. And they occur both in post and pre. Yes? But friction and anchorage slip don't occur in pre-tension. They occur only in post-tension. The answer is B. 35th question from RCC. The total side face reinforcement. The total side face reinforcement. What is the answer? The total side face reinforcement. Total side face reinforcement. Come on, fast. Total side face reinforcement. What is the form? What is the value? Side face reinforcement, right? So if we have RCC like this, beam section, this is the tension reinforcement, this is the compression reinforcement or hanger bars, we provide side face reinforcement also. So this side face reinforcement total is how much? It is how much? Tell me. Yes, it is 0.1% of the wave area. So answer is C. Very good. Remember this, 0.1% of wave area. Total is this. On single face it will be distributed. See, 0.1% then distributed in both the faces. Right? Next question is 36th question. This is from pavement design. This is from pavement design. Okay. Radius of relative stiffness. Straightforward formula. Okay. In many examinations they ask you straightforward formula also. Or they might ask you a numerical which is based on straightforward formula. So you should be knowing the formula. So which one is right formula here? Tell me. Which one is right formula here? Yes, the answer is B. See, it is E, the modulus of elasticity of concrete actually. Then the depth of the concrete slab cube divided by what? 12. K is the modulus of subgrade reaction. Then 1 minus mu square. Mu is what? The Poisson's ratio of concrete. Actually, it is concrete. Okay. Then to the power 1 by 4. Remember. Yes. So question number 36 or 37. Strength of material. Little good question. Read the question and solve. I'll give you some time. So it is good question. Some numericals also I put. So I'll give you some time. So solve this question. Okay. I'll sit some time. Yes, ladies and gentlemen, it's B. Yes, you see, we know that the shear stress distribution is inversely proportional to what? The width, right? The width. Yes, I told this before. So I can say the shear stress in the flange, this is in the flange, and the shear stress in the wave will be inverse ratio. Means what? The width of wave and width of flange, right? Now see this, what is given? The P point is in flange, right? So I can say the stress in flange is this, and stress in Q, that is what? In the wave we have to find. Now what is the width of the wave? The width of the wave is given 20. So 20. What's the width of the flange? It is given 100. So 100. So 5. So what I can say about the shear stress in wave? It is 5 into 12. That is how much? 60. Okay. Even you can find no, okay, it's good. No extra knowledge is required. Okay. So this is from strength of material. Question number 38 now. Okay, little bit RCC returns. RCC returns. Okay, little good question. Huh? Little good question. I put little good question. So please answer this question. The effective span, how much is the answer to this? So answer little attentively. Huh? Which is the right answer to this? I'll wait for your answers. I'll go a little backwards. So I become small now. And if I come front, I'm becoming a little bigger. I go sideways, no. Answer this question. The effective span. What is the effective span? Let us see who answers this question correctly. The effective span is the sum of what? LC plus effective depth and LC plus width of the supports, width of support, right? Whichever is small. So minimum of these two, right? So tell me now what is the answer? Now tell me what is the answer now. Tell what is the answer now. Tell me. Come on, fast. We are going slow. The answer is 6350. You see, this is the width of the support. This is width of the beam, not the support. Yes, and this is depth of the beam. You see, if we have drawing like this, sorry, something happened. It's hanging. Yeah. See, this is the column, and this is the beam, right? So we have to take the width of the support, this width, this is the width. Width of beam is something else. Suppose this beam is like this is the width of beam, right? It's different. Okay, so you can see that it is LC is given how much? 6 meter. So 6000 plus effective depth is how much? It is given 500. Yes, and then clear span is 6000 plus width of the support is given how much? 350. Minimum of both is this one. So very good question, and students do confuse in such kind of questions. Obviously you will not get confused. Question number 39 from rigid pavement, from pavement design. Solve this. From pavement design, solve this. Calculate the equivalent radius. Calculate the equivalent radius of the resisting section of 20 centimeter slab. Means what? The thickness of slab is given. And what else is given? The Ratio of radius of load distribution A and thickness of slab is given how much? 2. Yes, okay. So in this case, good evening Juhi. So in this case, we know that when A is less than 1.724 H, we had a complicated formula, right? We had a complicated formula for B, that is what? 1.6 A square plus H square, right? Minus 0.675 H. This was a complicated formula. But when A was greater than 1.724 H, what was happening? B was simply equal to A. So in this question, B is equal to A, and A is, by the way, how much? A is, by the way, 2H, right? So this will be 2 into H, which is 20, giving me how much? 40 centimeters. So the answer is what? Can I get rank under 100 by using YouTube lectures? Some students might get, but I will say that 99.9% won't get. So I will say that you should subscribe to some particular course. Okay, you will not get 100 rank by only following YouTube lectures. Someone might get, but not in general. Okay, let us go to the next question. Question number is 40. Okay, a 40 centimeter diameter circular timber column is 4 meter long. So this is the effective length of the column given, and this is the diameter of the column given. What is the slenderness ratio? What is the slenderness ratio? Slenderness ratio is L effective by R minimum, right? And what is R minimum? R minimum is root under I minimum by A. Yes. The minimum radius of gyration. All students have answered. Somebody has answered this question. Okay, very good. This is how much? I minimum. It's a circular section, right? Circular section means what? Pi by 64 d to the power 4. Now area of a circular section is what? Pi by 4 d square. So pi get cancelled. This becomes 16. This also get cancelled. Yes. So I get what? Root under d square by 16. So this is how much? D by 4, and D is 40, so I will get R minimum is how much? 40, I can write down as 4 mm, so divide by 4 I get 100 mm. So R minimum is 100 mm, so I will erase this. So R minimum is how much? It is 100 mm, right? And effective length is given 4 meter. Some students have found out the answer also. So slenderness ratio is what? L effective by R minimum, that is equal to 40 mm. Very good. 40. It's not, it's a ratio. So 40 answer is D. This was question number 40. Very good. So very nice coincidence, you see. Nice coincidence, you see. 40th question, 40 centimeter diameter, and the answer is also 40. Okay. Now, jokes apart, 41st question. Okay. So the previous question was from RCC. Now this question is from where? This question is from BMC, not BMC. Actually BMC we can say, because testing of aggregates actually. So testing of aggregates. So I can say BMC. And transportation also I can include. Even I can include in concrete design also. So tell me the answer to this. Solve this and tell me the answer. 41st question. Chalo. Testing of aggregates. This is the list 1 and list 2. Come on, very fast. Okay, we are going in good speed only because I am explaining also. But I will expect that you increase your speed also. B. Crushing test. Crushing test is for strength. So 4. Then Los Angeles abrasion test is for hardness. So 1. Soundness test is to check the resistance to weathering action. To 2. Angular test is shape test. So 4, 1, 2, 3. Answer is D. Answer is D here, na? 4, 1, 2, 3. So D, na? I think D. I have I committed some mistake. Crushing is 4. Los Angeles abrasion is 1. Yes. Soundness is 2. And angularity is 3. So 4, 1, 2, 3. Yes, it is D. Yes, D. 42nd question. 42nd question. Again, so soil mechanics, we again written so many questions on RCC and all. Now soil mechanics question. Answer this question. Okay. Which of the following laboratory method is used for determining the coefficient of permeability? Very easy question. Very easy question. Sometimes they ask you very easy question. Yes, both tests are conducted. Constant head we conduct for what? For your coarse grained soil, and falling head we conduct for your fine grained soil. But we do conduct both the tests, right? So the answer is what? Both 1 and 2. Very good. Question number 43. First. Now again RCC returns the maximum area of steel. Okay, what is the answer? Now I will give you some time to solve this. So solve this and give me the answer. Maximum area of steel. I'll sit for some time. Yeah, Karthik has replied, very good. So this is what? 4%, so 0.4 of B into D. Straightforward, so 0.04 into 300 into 500. This gives the answer of 6,000. Very good. So let us go to the 44th question. What is this? What this represents? EI, the triple derivative of Y with respect to X. What it represents in a beam? What it represents in a beam? Let us see who answers this question. Little interesting question. Okay, some people answered very good. It is the shear. Because you see, Y is the deflection. This is the beam. Y is the deflection at any point. This is the Y. Yes, this is the deflection. This is what? The deflection. Right? And dy by dx is what? Dy by dx is the slope, right? Is the slope. Okay. Now EI, double derivative of y with respect to x is what? It is the bending moment. Yes. And if you do the triple derivative, this becomes what? The derivative of bending moment with respect to x. And that is what? The shear force. So answer is D. Question number 45th. So this was from SOM, right? This was from strength of material. Okay. Let us go to the next question. So soil mechanics. Okay. So which of the following types of submerged soil is subjected to liquefaction under earthquake loads? So the following different types of submerged soil is more susceptible to what? Your liquefaction. Which is susceptible to liquefaction? Answer this question. C. Huh? C. Huh? Are you sure? Are you sure it is C? Okay. So I'll give you homework. So this question, write down about liquefaction in the comment section. Okay. And then I will reply. So some homework also. Every time I will only do the work. You will only come and then see. No. So liquefaction, you do some homework and write down a short note in the comment section. I will be happy if you do that. Short note in comment section and answer this question also. Okay. By this your answer writing will also improve. No suspense. Okay. Okay, no problem. But still you write down. 46th question. Write down short note on the liquefaction in the comment section. I will be happy. So decreasing tricalcium silicate and increasing dicalcium silicate. Oh. So C3S we decreased and C2S we increased. So what will happen? What impact it will have? This is from BMC, building material. So tell me, what impact it will have? What impact it will have on the cement? See, yes, it increases the resistance to chemical attack because C2S is responsible for providing resistance to chemical attack. See, heat of hydration is more for C3S. So C3S is decreasing means what? The heat of hydration will decrease, na? And C3S is responsible for faster gain rate of your strength. So C3S is decreasing. So these two are wrong. So answer is C. 47th. Okay, something on steel structures also. Steel structures. Bolted connection. The minimum pitch. Minimum pitch is dash times of dash. Hole diameter or bolt diameter. So what is the right answer to this? So many confusions are there here. So 47th question, let us see who answered it correctly. 47. Okay, we are going little slow. Fast. What is the answer to this? C? Yes. 2.5 times of D, so 2.5 times of bolt diameter. Very good. 48th question from your highway engineering. A vehicle, okay, has wheelbase of 6.5 meter. L is given. The off-tracking negotiating a radius of 32 meter curve. Very straightforward question. L square by 2R is the off-tracking, right? It is the off-tracking, so straightforward formula. 6.5 square divided by 2 into 32. Yes. You can do, this is actually 13 by 2, na? So 169 by 248, 32, right? 4. Okay. So this is also 240 something. So we'll get in the range of, this is 240 to 56. We'll get in the 0.66, na? 0.66. You see, you can do this calculation without calculator also. Okay, many students ask me, sir, how you to calculate in the ESE prelims examination. You can do without calculator also. Okay, not that difficult. So question number answer is D. Okay, next question is 49th question, straightforward from RCC. Critical question. Come on, answer very fast. Okay, answer very fast. Which of the following comes under limit state of serviceability? Limit state of serviceability. We have two limit state, collapse and serviceability. So which comes under limit state of serviceability? Come on, fast. We don't have time. B, yes, deflection and cracking. Very good. 50 question again from RCC. Side face reinforcement is provided when the depth of the beam is more than how much? See, we saw the percentage of side face reinforcement, but in which condition we provide this? This is from RCC. So 50 questions are over. Congratulations. Okay, 750. Very good. Question number 51st. Okay, from soil mechanics. Soil mechanics returns. Answer this. So in this session, mostly I have given questions from soil mechanics, RCC, strength of material, steel structures and transportation. 5 subjects I have mixed. Like this, in the next mixed civil session, I will not tell you which subjects I am going to put there. So you have to continuously revise your subjects so that whenever I conduct such session, okay, whenever I conduct a session, you are ready. Okay, so next session I will conduct after 10 days. That time also I am not going to tell you which subjects I am mixing. You have to keep on practicing questions. Okay, relative density formula is what? E maximum minus E by E maximum minus E minimum. So I can say that is 0.7 minus 0.5 divided by 0.7 minus 0.3. So 0.2 by 0.4, it is 50%. Answer is D. Very good. Question number 52. Tensile strength of concrete is ignored in which limit state? Tensile strength of concrete is ignored in which limit state? Tensile strength of concrete is ignored in which limit state? 52nd. Come on. Fast. Where we ignore the tensile strength of concrete, it's an assumption in both the limit states, or flexural limit state or compressive limit state. Where we ignore this, it's an assumption, very important assumption. The tensile strength of concrete is ignored in both of them. Okay, so when we are designing the beam and when we are designing the column, in both places we ignore the tensile strength of concrete. We only consider the compressive strength of concrete, and we assume that all the tension is taken by whom? By the steel. Okay, remember this again, that whenever we are designing a column or beam, RCC column or beam, we ignore the tensile strength of concrete. We assume that whatever tension is coming, that is taken by whom? The steel. And in concrete is taking the compression. 53rd question. Okay, soil mechanics. Time factor. Soil mechanics, time factor. Come on. Degree of construction given is 40%. So time factor is what? You see, this is less than 60%. When this is the case, what is the time factor? Tell us time factor formula. It is pi by 4 into u by 100 square, right? This is the formula, right? So I can say this is 0.785. You see, you can do an approximation also. You see, pi is 3.14, so divided by 4 is 0.785 approximately. This is 0.4 square. So I can say this is 0.785 785 into 0.16. So obviously it will be in the range of what? 0.121314, right? So answer is 0.13. See, you can do such calculations. You can approximate this as how much, you see? You can approximate this as 0.8 into 0.16. That will be how much? Approximately 0.144 something. So I can say little less than that, means what? 0.13. See, this is a very important thing that, you know, when you're appearing for ESE prelims or SSC JE prelims or your state services, we know that we are not given a calculator and we feel that without calculator we are useless fellows. No, it's not that. We are just not habituated of calculation. So whenever you are solving questions of ESE, SSC, JE or state engine services, make an habit that you keep your calculator away. See, I don't have calculator over here. Okay, keep calculator away. So answer is C. 54th question. Okay, theoretical question from RCC. When the mild steel is replaced by HYSD steel bars, what happens? When mild steel is replaced by HYSD steel bar, what happens? Tell me the answer. B, yes, bond stress increases by 60%. Very good, straightforward. 55th question. Okay, when the fusion angle is 104, so we have two members like this and we are doing a welding and the fusion angle is what? It is 104. It is 104 degree. So what is the effective throat thickness? It is K into S, na? So what is the value of K? Tell me. Tell me the right answer to this. So welcome Devi Prasad. Hydrology is also there. Okay, very good. Hydrology is there. So what is the answer to this? From 60 to 90 we have how much? 0.7 S, right? From 91 to 100 it decreases by 0.05. It becomes 0.65. Then 101 to 106 it becomes what? 0.6 S. Then from 107 to 113 it becomes 0.55 S. And then less than that 0.5. So it is what? 0.6. Very good. This is from steel structures, right? This is from steel structures. Question number 56. Okay, again from RCC. What is the maximum spacing of vertical stirrups if the effective depth is given 300 mm? Come on, answer this question. All of these questions are frequently asked in many examinations, yes, but I have to identify them and put in such a way that we have regular revision of, you know, mixed sessions. So hope you are all liking this mixed sessions, yes. So this mixed session is a, we can say I have started this mixed session this year. Okay, I have been conducting this session previously also, but last year I was a little busy, so I couldn't conduct such sessions. But this session, these mixed civil sessions, I will conduct very regularly. Every 10-15 days I will be conducting these sessions because the final examinations, all the subjects will be mixed like this. And if you are only studying a few subjects, okay, and you're not habituating yourself for such sessions or such practice, then in the final exam you are going to face difficulty. So answer is what? 0.75 D. So answer is 225. Very good. 57th question. Okay. Okay, RCC again. RCC returns. So long question. So I request you read the question carefully. Read the question carefully. The shear strength of concrete, tau C, depends on what? Read the question carefully and answer me, okay? See. The tau C depends on FCK. Yes, it depends on FCK. It depends on the shear reinforcement percentage? No. It depends on the longitudinal percentage of longitudinal reinforcement in tension. Yes. It depends on the total. No, it don't depend on total longitudinal reinforcement. It only depends on the tension reinforcement. So answer is 1 and 3, that is C. Question number 58. Okay. Column design, steel column design and lacing design. From lacing, a steel built up column is subjected to an axial force of this is the factored axial load. The lacing system has to be designed for a transverse shears. What is the answer to this? Solve this and give me the answer to this. What is the transverse? Yes, it is 2.5% of the longitudinal load. So I can say this will be how much? This will be 50 kilonewton. Very good, students, very good. Question number 59. Okay, again RCC returns. The minimum strain at failure in the tension reinforcement of RCC when we have Fe415, or it is indirectly what? The yield strain. It is indirectly asking what? The yield strain, because this is the minimum strain at which failure will occur. So the yield strain value for Fe415. For Fe415, it is how much? The formula is what basically? It is 0.87 Fy by Es plus 0.002. This is the strain formula, right? You put here 415 and this is how much? 200 per 5, you will get a value of 0.0038. Answer is D. Very good hydrology. Next question is 60 question. Okay, load factors. Load factors. So RCC only. Okay. Design bending moment, when we have dead load as this, dead load bending moment is given as 20, live load bending moment is given 30, and seismic load means what? The earthquake load, right? Is given 10. The wind load is missing here. So tell me the answer now. Tell me the answer. Let us see. 72. 72 or 75? 72 or 75? The answer is 75. Because you see, we have to consider this combination also, na? Dead load plus maximum of live or earthquake. This combination, when you take this combination, then how much are you getting? 1.5 of 20 plus, sorry, not earthquake, we'll take live load because that is the highest one, right? 20 plus 30, I am getting 75. When I take this combination of 1.2 dead load plus live load plus earthquake load, then I am getting 72. But I have to take the maximum one, so I'll use the 75. So answer is B. Question number 61. Come on. First, the limiting depth of neutral X is H per IS 456 means what? XU limiting, it depends on what? XU limiting depends on what? Grade of concrete, grade of steel, both or none? It depends on what? Tell me, come on. Answer the question. B, others BC. Okay, depends on only grade of steel. Because you see the formula is K into D, right? And this K formula is what? It is 700. Yes, 700 by what? 1100 plus Fy. So it only depends on the grade of steel, not grade of concrete. Okay. Question number 62. Deflections are controlled by, very straightforward theoretical question. Deflections in RCC beams are controlled by what? Very simple, straightforward question. Yes. What is the answer to this? It is what? Come on, tell me the answer. D? Yes. Span by depth ratio. Or depth by span. This is span by depth ratio. So answer B is given just to confuse. It is depending on what? Span by depth ratio. So please do look at the options before answer. 63rd question. Good. So some few questions from surveying also in between, right? Okay. Okay, it's a question on local attraction and true bearing, magnetic bearing. Please read the question and at your time and solve this. I'll take a break then. Very good. Many students found out also. You see, the past in an old map, old map means what? Past. The magnetic bearing is given as 5 degree 30 minutes. Okay, it is 30 minutes actually, mistyped. And the declination is given 1 degree east. So true bearing will be how much? True bearing will be magnetic bearing plus the declination in east, right? So plus 1, it is how much? It is 6 degree 30 minutes. Very good. Now in present what has happened? The declination is 8 degree 30 minutes. But the formula will remain same, and what? True bearing remains same. So the true bearing remains same, only declination has changed and it's still east. So I'll add, right? When it's still east, we'll add. The true bearing will still remain as 6 degree 30 minutes. So from here the magnetic bearing will get how much? Minus 2 degree, and minus 2 degree is what? It is actually 358 degree, right? We can say like that. So answer is A. 64th question. Okay. Theoretical question. From RCC, the strain distribution. We all discuss about the stress distribution, but it is asked here what? Strain distribution. Strain distribution is always linear. Strain distribution is always linear. Stress distribution is what? It is first constant and then parabolic. Yes. You see, this is the stress distribution of RCC beam, and this is the strain, and strain is always linear. So answer A. 65th question. Okay. Design shear stress of fillet weld. It is soft weld. Soft weld. So what is the answer? Design. So this is from steel structures. The design shear stress for a fillet weld having soft weld. Soft weld means what? Gamma MW is how much? 1.25 or 1.5? That is the case. So answer this question. Yes, it is soft weld 1.25. Yes, soft weld. See, when it is filled weld, it will be 1.5. Soft weld means factor of safety will be less because quality will be better. So answer is this. Yes, and we use what? FU. So FU by root 3 is the stress. Then we divide by what? The factor of safety here, gamma MW. But the gamma MW is 1.25 for soft weld. Next question, 66th question. Okay, RCC columns. If the slenderness ratio is 6.5 for RCC column, it is designed as what? Come on, bro. Tell me the answer. If a RCC column is there whose slenderness ratio is 6.5, so it is designed as what? A pedestal, short column, long column, what? It is designed as short column. Yes. So the slenderness ratio, when it is less than equal to 3, then we can say it is a pedestal, right? It is greater than 12, we'll design as a long column, right? If it is less than 12, I'll design as a short column. Next question, 67th question. Okay, risk. Yes, some hydrology question also. A bridge has an expected life of 25 years. Okay, it is designed for a flood. Magnitude of return period, how much? Return period is given 100 years. What is the risk of this hydrological design? What is the risk of this hydrological design? Risk. What is the risk formula? We know. Risk is what? What is the probability of risk? See, probability of risk means what? No failure, right? Or I can say the risk probability will be 1 minus no failure. Yes? No failure. This is 1 minus no failure. See, failure means what? That there is, this flood is coming back in that year, right? So the probability is how much? The probability of the flood coming is 1 by return period, so 1 by 100, right? So no failure means what? It will not occur in the entire design life. So I can say 1 minus p to the power n, right? So I can say 1 minus no failure. No failure means what? That 1 minus p, and it has to be for the n years. Every year there will be no failure. So it will be by n, so it will be 1 minus 1 by 100 to the power 25, right? Yes. And this is which one? 1 divided by 100, so answer is C. Important question, 68 question. So another thing I wanted to tell you from this question on hydrology, that you see sometimes we feel that this calculation is complicated and they might not ask in the objective pattern. But that is our illusion. Why? Because they might not tell you to calculate, but they might ask you to write down the expression. They mention 4 expressions here like this, yes. So some questions where calculation is not possible also, still you should solve them very nicely. Why? Because in the objective pattern, what they can do is, they can write expressions like this. And then you will be like, oh my god, why I didn't study it? Yes or no? Yes. So they might not ask you to calculate and give the value because there is no calculator, but they can certainly ask you expressions. Next question, 68th question. Effective span of a cantilever beam. Very straightforward question, answer this. Effective span of a cantilever beam, answer this. 68 question, 30 questions to go. Yes, clear span plus your d by 2. Very good. RCC. Next question is 69th question. 69th question. Okay. The equivalent shear stress of weld is subjected to a shear stress of Q and a bending stress of F. Equivalent shear stress. What is the formula for this equivalent shear stress? Where we have both F square plus Q square. But we have a 3. It is associated with what? Which one is the right answer here? C, yes. It is associated with the shear stress. So answer is this. Very good. Steel structures, right? Welding structure, weld connection, 70, again RCC. So we know that in the span by depth ratio, we have some correction factors also associated. Now, which of the following correction factor is not applied? Read the question carefully. It is then not applied. We are not applying those correction factors. We are not applying those correction factors. Tell me the answer. We are not applying the correction factors. So today I am little moving also. Every time I am, sitting in the chair and, I was feeling a little bored. So I thought that let me now conduct the classes where I'll be moving also, right? So that you also don't feel bored. Otherwise, seeing the teacher, always sitting like this, constant for 1 hour and all, feeling boring. So what's the answer to this? D, yes. There is nothing called this torsion steel correction factor. This is KT, this is KC, and this is KM. 3 correction factors. Very good. Question number 71. So some opens and follow also returns. 71. OCF. So for a hydraulically efficient triangular section, it is triangular section. Now what is the hydraulic radius? R. If you have a triangular section, it is not rectangular, it is triangular. Yes. If this is the depth, central depth y, then this is y by 2 root 2. Remember this. For triangular efficient, this is the answer. Now R is equal to y by 2. This is applicable for what? This is applicable for rectangular and trapezoidal channel only. Okay. It is not applicable for triangular. It is y by 2 root 2. Very good. Question number 72. Okay. Something on steel structures. Again, steel. So the percentage reduction in shear strength for a packaging plate being used in joint. For a packaging plate being used in joint. Very good, David on Hill. Very good. Good student. So percentage reduction. For this we need this correction factor for packaging. What was the formula? It was 1 minus 0.0125 into thickness of the packaging plate, which is given as 10. This factor is how much? This factor we are getting as 0.875. Yes. So reduction factor will be, reduction percentage will be how much? This factor is multiplied, right? Suppose it was 10. So if you multiply this, becomes how much? 8.75. Yes. If you multiply, initially it was 10 suppose. You multiply this factor, you will get 8.75. So what is the percentage reduction? It is 10 minus 8.75 divided by 10 into 100, getting how much? Getting 12.5 percentage. 12.5 percentage. So this is the reduction factors in the shear strength when we have packaging plates, right? Suppose we have like this. I will draw here. We have, one main plate is like this. The other main plate is like this. Yes. To provide some packaging here. Yes. We provide some packaging here. Yes. So due to this, there will be reduction in the shear strength, and that depends on the thickness of this packaging plate. Okay. Next question, 73rd question. Okay, RCC returns for footing. Tell me the answer to this. for a footing. So suppose this is the footing and we have a column also. So we have some critical section where we find certain parameters. This is the column, and this is the footing. Top view, na? Top view. Now tell me which is the right answer. Match the following and tell the right answer to this. Go on, fast, fast. See? See, punching shear. See, we have one critical section here. We have another critical section like this. Yes. The two-way shear. Yes. And we have another critical section like this. Three critical sections are there, right? Three critical sections are there. Yes. If you see this, this is at D distance from the face. So this is what? This red one is what? For one-way shear. So one-way shear is what? D distance from the face of column. This green one is what? The two-way shear, and it is D by 2. So I can say this is the punching shear or two-way shear. This is from D by 2. And face of column here, this is punching, you can say punching or two-way shear, right? Punching, or I can say two-way shear, right? And at this section, what we find out? The bending moment. So bending moment is the face of column. So I can say 3, 2, 1. 2, 3, 1, sorry. So answer is D. 2, 3, 1, answer is D. And everyone? Yes, very good. 74th question, we are going slow, Baba. Come on fast, come on fast. No problem. Anyhow, we have the studio booked till 7 o'clock. I have kept little, we can say, factor of safety, but still we should complete before. So that, we will feel good that we are able to solve the questions fast. So during CU test, drainage is allowed in which stage? CU, what is CU by the way? It is consolidated undrained. Yes. And which is the first stage? The first stage is the consolidation stage, right? First stage we have consolidation stage, and second stage is what? The shearing stage, right? Second one is the shearing stage. So when I'm discussing this drainage, so it is written consolidated means what? Consolidation is allowed means what? Drainage is allowed, so tick. Now next is that undrained. Undrained means what? Shearing. Undrained means what? Shearing. In that undrained means what? Drainage is not allowed. Yes. So answer is what? Drainage is allowed only during the consolidation stage, option B. Yes. See, if it was, CD test. CD test means what? Consolidated drain stage. Yes. Consolidated drain. In that case, what will happen? Tick, tick. Yes or no? Both stages. If it is UU, then what? Not allowed in any stage. Yes. Next question. 75th question on pre-stress concrete. Come on, answer this question. Theoretical question, pre-stress concrete. 25 questions to go, 26 questions to go. Let us see, can we complete it before 6:45? Come on. Chalo, jaldi, jaldi. Which of the following is a long-term loss? Which of the following is long-term loss? B is not long-term loss. Friction loss is not long-term. Friction loss happens instantly. No, friction loss is not a long-term loss. See, friction loss, elastic shortening loss, and your what is that? Slip loss. These three are, immediate losses. Long-term losses are what? Your shrinkage and your creep and relaxation of steel. So relaxation of steel. Next question. 76th question. One question irrigation also I have put in between. Irrigation. Come on, answer this question. The ratio of water stored in the root zone. Water stored in the root zone to the water delivered to the field. This efficiency is known as which efficiency? This efficiency is known as the water application efficiency. It is water application efficiency. What is conveyance efficiency? Conveyance efficiency is how much reached the field divided how much was diverted to the field. That is conveyance efficiency. Yes. What is storage efficiency? How much is stored in the root zone divided by how much is what? Delivered to the field. Right? Okay. No, not that is different. It's different. So what we are started discussing is your water application efficiency, that is stored in the root zone by delivered. Okay. Conveyance is what? How much reached the field divided by how much was diverted from the canal, right? Water storage is, I think, how much is stored in the root zone divided by how much is applied after losses. Yes, means I can say water delivered minus losses. That is water storage efficiency. 77 question. Okay, distribution steel. Okay, RCC returns. So distribution steel, answer this question fast. Come on, jaldi jaldi. Distribution steel in one-way slabs, in Fe 415 steel and maximum spacing. 415 means what? HYSD, right? Yes. Distribution steel 450. 450 distribution steel is not main steel. Main steel is 300. Main steel is 300 is distribution steel. So answer is this one. You see, 0.15 percentage for mild steel, and for HYSD it is 0.12 percentage. So 0.12 percentage. But then we told what? It is distribution steel. For main steel it is 300. For distribution it is 450. Next question, 78th question. Tensile strength of a tension member formula. Steel structures. Come on, answer this question. Yield strength in strength of a tension member. Let us see who answers this correctly. All formulas become confusing, therefore it's very important that we revise the formulas. The formula is stress into area divided by factor of safety. Now whenever we are finding this yield strength, the factor of safety will be gamma m naught. And yield strength, so it will be Fy. And whenever we are finding the yield strength, we take the areas at the gross area. So answer is which one? D, Baba, D. It is D. See, try to understand. It is yield strength, so stress I will take Fy. Area I will take the gross area and gamma m naught. Yes. See, if it was rupture, if it was rupture strength, then stress I would have taken 0.9 Fu, area I would have taken net area, and factor of safety gamma m1. So this formula is for what? This is for what? This is for rupture strength. And these two formulas don't exist only. These are two imaginary formulas, don't exist only. And this is the tensile strength. This is the yield strength, yield strength. Both are tensile strength only. This is the yield tensile strength, this is the rupture tensile strength. Hope now you remember the formula, right? Now remember the formula. Very good. Then next question is 79th question. Okay, open channel flow returns. OCF, answer this question. The critical depth is given for a rectangular section. What is the specific energy as critical grade? Means what? The critical specific energy. What is the answer to this? Very straightforward question. Come on, answer this fast. Come on, answer this question very fast. Come on. Chalo, jaldi. We have 21 questions to go. So let us have a IPL mode. So we have to complete before 6:40 suppose. We have to complete before 6:40 p.m. So we have how much time? We have 12 minutes. So 12 minutes and 21 questions, like 12 balls and 21 runs kind of thing, right? So it is 1.5 of YC. So giving me 3 meter. Very good. We are doing very good. 780 question. Okay. Degree of saturation soil mechanics. Very simple, straightforward question. Okay. Use the relationship which we know before and solve this question. Come on. Some numericals also. Not all are theoretical question. Solve this question. We use this relationship, right? SE is equal to WG, right? Right. So S is equal to W, which is 15%. G is given 2.5, and then void ratio is given 0.5. Very straightforward question. Very straightforward question. Answer is what? 75%. That is C. Next question, 81st question. Oh, wind pressure, steel structures. Wind pressure. Okay, when the wind speed is 40, what is the formula? The wind pressure is 0.6 of your wind speed square. So remember this formula. Nowadays, they're asking questions from your wind design. Okay. So this is the formula. But here we'll get the answer in Pascal. So if I want in kilopascal, what I will do? I will simply divide by 10 to the power 3. And this I will take in meter per second. So formula becomes 0.6 into 40 square divided by 10 to the power 3. Yes. So we'll get 0.96. We'll get how much? 0.96. So very simple formula, but you should know, otherwise you will not be able to solve this question. 82nd question. Okay, irrigation engineering, very straightforward question. Answer this question. Irrigation engineering, very straightforward question. Answer this question. What is called as the percentage of CCA? What is CCA? CCA is the cultivable command area irrigated at a time in one crop season. What is this answer? So they're not asking you the definition of CCA. They're asking you what is this thing called the percentage of CCA which is irrigated. Yes, the answer is intensity of irrigation, right? Intensity of irrigation is the percentage of CCA. So it's like, you see, total area is gross. Total area is gross culturable, gross command area. Then out of this there will be certain area which will be culturable. This is what? CCA. But you will not irrigate the whole thing at one go, na? Suppose you are irrigating a certain portion of this in one crop season. That is means what? This will be known as what? This divided by this CCA known as intensity of irrigation. Answer is D. 82nd, 83rd. Okay, another question from OCF now. Come on, fast. You see, you can see that I have done ultimate mixing of questions. Ultimate mixing of questions from OCF, irrigation, then RCC, steel structure, strength of material, and then geotech. Yes. So this and then also some questions from highway engineering. Yes, airport, railway. So I've done a lot of mixing here. Okay, I've done a lot of mixing here. And next sessions I will be mixing some environmental also. But I will not tell you which subjects I will mix. I will never tell you. That is the suspense. Yes. So what is this answer? Channel slope. Okay. What is the answer to this? What is this? Mild or slip? See, normal depth is given 0.8 meter. Critical depth is given how much? 1.07. That means what? The CDL is above the NDL. When CDS is above NDL, and this is the bed. This is which slope? This is your steep slope. This is steep. Yes. When the critical depth is more than the normal depth, this is steep. When the normal depth is more, then it is mild. And when they're equal, they're critical. So answer is steep. 84th question. Okay, what is the compression index? CC. That question was from what? That question was from OCF, and this question was soil mechanics. Come on, answer this question. Very easy question. We also solved this definition of few questions before also. So answer this 84th. We are going very fast. Very good. 20 students are watching the lecture live and recorded. I don't know how many. That we will see later on. So 0.3. Very good. This is what? CC is what? Delta E by log 10. Sigma 2 by sigma 1. This sigma 2. This is sigma 1. So sigma 2 by sigma 1 is 10. So log 10 is 1. So delta E is how much? 1.5 minus 1.2. So 0.3. Very good. 85th question. Alternate depth in case of open channel flow. What is the meaning of this alternate depth? Answer the question. What is the meaning of alternate depth? What is the meaning of alternate depth? What do they have common in alternate depth? What is common in alternate depth? Tell me. What is common in alternate depth? See, if we draw, Y versus specific energy, we know that we get a curve like this. So at a particular specific energy, you can see there are two depths, and they are known as what? The alternate depth. So they have same specific energy for a given discharge. So answer is C. Very good. 86th question. RCC and steel. This is applicable for RCC also, and also as per IS 800, this is the same provision. What is given? Has both translation and rotation restraint at one end. At one end, I can say both translation and rotation is not allowed, while only translation is restrained at the other end. Means rotation is allowed. Means rotation is allowed. Means what? This is fixed end, and this is what? This is pinned. Because in pinned, the rotation is allowed, but translation is not allowed. Is restrained means what? Not allowed. So in this case, what is the effective length factor? What is the effective length factor? What is the effective length factor? It is 0.8. See, theoretically it is how much? See, actually this becomes L effective by root 2. So I can say how much? 0.707 L effective. Sorry, means L by root 2. L. But thing is that as per code, there is nothing called complete fixity. Therefore, it takes how much? 0.8. So answer is 0.8. Understood this question? Yes. Both translation and rotation restrained at one end. Restrained means what? Not allowed. And only translation is restrained at other end. Question, very good. 87th question. Something on traffic engineering. Let us see who answers this correctly. 86, 85. Okay, 87. Okay. This is of traffic engineering. Come on, answer this question. Let us see who answers this question correctly. Safe speed limit is xth percentile speed and design speed is yth percentile speed. So what is the answer? Read the question completely. Don't jump. Don't jump. Don't jump, Baba. It is y minus x is asked. Y minus x is asked. Don't jump. Read the question. Very good, Sajid. Very good. Very good. Yes. See, this is 98th percentile and safe speed is what? 85th percentile, right? So it is asked 90 y minus x. So 85 minus 98 minus 85. That is the answer is 13. So sometimes read the question carefully. Don't jump. Don't jump. Very good. Question number 88. We are going towards the end. So some questions on hydrograph also. Hydrograph. Chalo, batao. Means hydrology. चलो बताओ. D. See, we have a 4-hour hydrograph. 4-hour hydrograph is something like this, and its base is 60. Its base is 60. Its base is 60. So answer is how much? So 12-hour hydrograph. How will get the 12-hour hydrograph? By repeating this 4-hour hydrograph 3 times. Right? So 1, 2, and 3. With a delay of how much? With a delay of 4 hours. So this is 4, and this is also 4, and this is 60. So the total one, how much I will get? 68. Answer is 68. Understood, everyone? Understood, everyone? You see, here originally it was how much? Where is that red one? Yeah. Originally it was from here to here. Then this is the first one. Then we repeated. Second one, this is the first one. Second one repeated, but delay is 4. So here also 4. Then the third one, we repeated after delay of 4. This also 4. So total becomes how much? 60 plus 4 plus 4. Good question. Next is 89th question. Okay, this is from your bitumen test. So this is from your, we can say, highway materials, or I can say pavement materials also. So answer this. Penske-Martin test. It is associated with which test? Which apparatus? Yes, it is plus and fire point. Next question is 90th question. Okay. Soil mechanics. So we are approaching. Very good. Soil mechanics. Come on. You have to complete by 6:45. 10 questions, 7 minutes. Come on. Coefficient of permeability is halved. Coefficient of permeability is K. And coefficient of volume compression, MV, is doubled. So what will happen to coefficient of consolidation? What is coefficient of consolidation? It is what? It is K by your gamma W MV. So K is halved and MV is doubled. Right? So what happens? This is K by 4 times of gamma W MV. So this was original C. So decreases by 4. Decreases by 4 times. Answer is D. Doesn't increase. See, 4 times you understood. But it is increasing or decreasing? It is increasing. Why? Because whatever was original, I am dividing it by 4. So it decreases by 4 times. Next is 91st question. Theoretical question on pavement design. Answer this. Theoretical question on pavement design. Very straightforward question. Bankel beam deflection method is used for design of what? Come on, fast. Very simple question. So overlay means what? Already there is a layer. We are putting another layer, right? So already there is a layer. We are putting another layer. So what we can say? So which is the answer to this? C. Yes. Flexible overlays on flexible pavement. Already there was a flexible pavement, it was damaged, so we are putting another flexible layer as a repair, we can say. So see, 92nd question. Dimensions of Manning's constant. N. Answer this. OCF. Answer this. Dimension of Manning's roughness coefficient. You can use the formula also. If you get confused in this, now you can use the formula. 1 by n, we revise this also. R to the power 2 by 3, then S half. You see, velocity has the unit of what? Meter per second. Velocity has the unit of what? Meter per second, right? So meter per second, yes. This is 1 by n. This will be meter only, na? Meter to the power 2 by 3. And slope doesn't have any unit. So I can say from here n will be equal to m 2 by 3, and I can say minus 1. Then multiplied by second. So I can say meter to the power minus 1 by 3 and second. So length dimension by 1 minus 1 by 3 and second is time. So answer is B. Very good. 93rd question. The minimum percentage of tensile steel, PT minimum, for beams having FE 500. This is from RCC. So RCC 3 tons again. Answer this question. Answer this question. Okay. Now I'll request all the students that if you're liking such sessions, which type of sessions you want in the upcoming YouTube sessions, so please write in the comment sections, okay? Not in this comment section or the live chat comment section. After the video is over, you can return after 1 hour. Whatever you feel like, you write in the comment section that which type of sessions you want, okay? I'll come up with such kind of sessions. You can write down your choices, whatever you are needing, okay? Please write in the comment section. I will conduct such sessions in the future along with the planned sessions. This is nothing but 85 by Fy, simple formula. So it is 85 by 500 giving me how much? 0.17 percentage. 94th question, quicksand condition occurs, is found in what? Quicksand condition found in what? Which is the answer to this? Where do we get the quicksand condition? Soil mechanics. Yes, we get in silty sand. We get in silty sand. We don't get in clay because in clay there is cohesion. Yes, and gravel we also not get because there the head will be very high requirement. 95th question, equivalent axle load factor. Ooh, EALF. So this is from where? This is from pavement design. Flexible pavement design. So answer this. Equivalent axle load factor for an axle load of 160 kilonewton. Okay, so axle load is given 160 kilonewton. So what is the EALF? What is the formula, by the way? Axle load by standard axle load to the power 4. So I can say it is 160. Type of axle is not given, so I'll take 80 to the power 4. So 2 to the power 4 is 16. Answer is B. Next, 96th question, flexural collapse in over reinforced beam, which is which categorized? RCC. The collapse which we get in over reinforced beam, this comes under which category? Primary compression, secondary compression, or primary tension? What is the answer to this? Over reinforced beam, we get what? What fails? What fails first in over reinforced beam? First, concrete reaches the maximum strain and fails. So it's a compression failure and primary compression failure. Very good. Okay, next is 97th question. Okay, critical flow means OCF again returns. So what is written? The minimum specific energy, you can say specific energy in critical flow occurring in triangular channel is given by how much? What is the relation between your YC and this? Answer, yes, it is 1.25. Very good. See, this is for triangle. This is for a triangular channel. Yes, for rectangular channel same formula changes to what? 1.5. Remember this. We have solved one question also. The answer is A. Next is 98th question. Okay, from payment only, payment materials or bitumen test. The softening, while you are measuring conducting the softening test, what you are actually measuring there? What is result is expressed in what? See, we are measuring the thermal susceptibility, or I can say the sensitivity of the bitumen to temperature changes. But actually what we measure there, the result is expressed in temperature. Softening point is a temperature. Yes, it is a temperature at which we get a certain degree of softness. 99th question. Okay, 2 questions more to go. We'll complete before time. Very good. The maximum allowable shear stress, tau C max, it depends on what? Grade of steel, grade of concrete, both, none, what? Sorry. Yes, it depends only on grade of concrete. It is approximately 0.625 root FCK. It only depends on grade of concrete. See, it depends on grade of concrete and percentage of tensile steel. That is what? Tau C, no tau C max. Very good. 100th question. Okay. So this is from pavement design only, pavement materials. So in Marshall testing, as the bitumen increases, bitumen percentage increases, what happens to the flow? Flow is what? The deformation, right? So if you have a Marshall sample like this, if you are applying a load, so if the bitumen percentage is more, then what will happen to the flow? The flow will increase, will keep on increasing, right? Because more is the bitumen, more it will be what? It will be flexible, it can flow more. So increases monotonically. So great, 100 questions we solved in 105 minutes, almost 1 hour 45 minutes, and you can see that I completely mixed questions of open channel flow. Yes, we have transportation engineering, we have soil mechanics, we have RCC, we have steel, we have strength of material. So 5-6 subjects I mixed very nicely. We will conduct more sessions like this. So what is my your work also? So if you like the session, okay, what you do is that after this session is over, okay, come back after 1 hour, and in the comment section you mention what you liked about the session, and also write down which type of sessions you want in the future. This is the first thing you should do. If you feel that you are benefited, so write down this. Yes, and if you want to join my group, so what you can do is you can message me to this number. I will not, I see normally what happens is that the teachers, they share a Telegram group, which is very good, but I don't share my Telegram group. What I will do is that I am giving you my number. So first of all, you can message me. If I find you interested enough and a serious aspirant, then only I will add you in the group. Yes or no? So you message me to this number, okay? You message me to this number and then tell what is your condition and all, and then as per your interest and sincerity, I will add you in the group, okay? So second thing. Third thing is that homework. I told you that you should write down about the liquefaction question was there, na? That liquefaction question was there. Where the liquefaction question went? Dear liquefaction, where are you? Wherever it was. 40 something it was, na? Forgetting. Okay, that liquefaction thing, what you do, liquefaction thing, you write down a short note on liquefaction and that answer to this. And this is special question, so homework to this. Another special question, last question, extra 101st question. So normally 100 question we have solved, the 101st question. This also is the homework. Don't write now in the comment section. Okay, write down after the video is over. So thank you very much. Hope you like the session. So thank you very much. Bye bye.